I feel so tired today, I don't know why. Maybe it's good to cancel the class, huh?
Yeah.
Please oh no, I'm kidding. How possibly I can cancel the class? That's for calculus. How possibly? It's gonna be so much fun. Who said yes? Who said you cancel the class? I'm gonna give 0. Okay now. Guys, please everyone listen. Today, I still remember the question which Tara asked me yesterday to use, I should say, a kind of a special rule for the logarithmic. I'm just going to do this at the end of the class today. What time the period ends today? 12, 1:10, huh? 1:15. 1:15. Okay, now, today, although we are just going to change the gear a little and talk about the derivative. Also, I'm going to go to Tara's question, which she asked me yesterday, the square root of ln of x. But today, we are just going to focus a little bit. And also, guys, next week, the same time, we have the second summative test, just for the things that we covered, derivative of exponential functions and trigonometric functions. That's right. It's next week at the same time. It's just these 2 sessions that we have had. Compared to the first, compared to the first summative test, to be honest with you, when I heard it myself, I was surprised. Oh, next week? Yes. Exactly next Wednesday.
Oh.
And then, honestly, when I heard it myself, I was surprised. How possible next week is going to be another test? But anyhow. But guys, everyone, please. Tara and Dom. But the second test is going to be very easy because it's just 2 laws: exponential functions, Tommy, and trigonometric functions. Compared to the first summative test, that you had to cover a law, the limits, the continuity, the derivatives, the definition of the derivatives, the power rules. This one is very easy. Now, then let's get started.
Wait, Mr. Madonna.
Yes.
A lot of us will be here because we have our IA data collection for biology.
Oh, really? Then I think you get 0. No worries. I'm going to talk to Rania, Mrs. Zaveri, and we come with an alternative solution for that. No 0. No one gets 0. Yes. Okay, now guys, we have a lot to do today. Then please listen. Guys, if you remember from also, we had a little bit, I should say, on the review session at the beginning of the term, we had to talk about 2 functions. We talked about the code. Let's start with the sine first. That's my favorite function to start it with first. We just talked about, for example, the sine of x. We said that the sine of x is one of the trigonometric functions, and now today, without proving it, because it's out of the scope of the IB program, without proving it, we accept that the sine x, you can just try it using the definition of the derivatives that we covered before. You can start it and prove it, but if you can do that, you get this result that you say that the rate of change of the sine x, when x changes, it's going to change it with this rate, cosine of the x. We accept it, we do not prove it. Now, also, we learned today that d over dx of cosine x is going to be minus sine x. We do not prove them as I said, we take them as they are. If we are interested to prove it, we can set another session out of these periods that we have. I prove them for you. Otherwise, with the IB program, you do not need to know that at all. Okay, now, let's do something so fun. As the first example, which I'm going to, let's see if it's captured on the camera. As a very first example, I give you a function, and function. This is on page 2. This is cosine of 1 plus x cubed. For example, we just want to find the derivative of this function. You come here and see that, oh, I know that. If this is x, and if this is x, the derivative of that group becomes cosine x. But I come here and see that for this particular function, I say, what is the derivative of this? Cosine of 1 plus x to the power 3. And that's the problem. Now we say that sigma, we see that, we are looking for the x, but Math 2 is telling me, this time I'm right, huh? This time I'm right about the name. Yes. But this time, we see that we are looking for to measure the changes with respect to the x, but now you see that the function comes with 1 plus x to the power 3. Then you ask, for example, Don is asking me, how is it possible to find the rate of change when this one is not x anymore? Instead of having the x, for example, cosine x, I have cosine of 1 plus x to the power 3. How is it possible now to solve it? Now, I say, no problem, I just give you one kind of a solution. We say that in order to do this, again, I have to remind you of the story of a mother and its baby, which is not born yet. And when we look at this one, it reminds us the mother function is going to be the cosine x, and now she is pregnant with this baby, 1 plus x to the power 3. And now it's going to be that function. I'm going to write it now then as y equals to cosine of 1 plus x to the power 3. Then you say, oh, when I look at this mother and the baby, I say, hey you, look at how I'm calling you, hey you. What do I mean by hey you? It means that you take the baby and say, I'm going to call this instead of, for example, Stephen, I'm going to call this you. I say, hey you, and now I change its name. Now that I change its name, I'm going to rewrite it like that. I put 3 points, for example, it says that they are actually the same thing, no differences. Then I say now it's y equals to cosine of u. But now, it's somehow very similar, Gabriel, to the cosine x. But now I called whatever was the baby, I called it u. Okay, now, but I know still I'm careful because I know that I just want to find the changes of this baby within this mother when x changes. Now, then I have to continue. In order to continue, I say that I know that I have to find this one b over dx of y. I know that. This is essentially, you know that, you can say that it's y equals f of x, something like that. I know that. I have to still, although I call the baby u, still I have to find d over dx, d of y over dx. Now, look at this. Now, I say that I keep dy here, and I keep dx over there. Look, please, guys, everyone listen carefully. This part of the course is going to be like, for example, you are doing a neurosurgery. You are working with very fine instruments. Now, I put my y there, and I put d of x there. Why? Because I know that I have to find these ones, dy over dx. But I push them, I separate them. I have 2 empty spots. I have to fill them. Sebastian and Ruth. I have to fill these 2 spots. And these two spots is going to be filled by what? By the baby. Why? I say that now. I put du and du. Look at this one. By doing this, I haven't done something crazy yet. Because if you look at this, you say, am I insane? Why did I do that? Because they are multiplied. These du, they are going to be canceled out. And you are left with dy over dx as what you are here. And that's what you expect to find. Then what was the reason that I did this? Now I tell you, don't worry, look what's going to happen. I look at this one, dy over du. What is my y? When you call the baby u. This is cosine of u. That's correct? Because when you look at the mother and the baby, you said, oh, hey you, you call the baby u. Whatever is inside, it's called u. Right? You can call it hey v, then you call it v. Anything you want to call it. Now, dy over du. What is that? I'm just going to write. I know that it's equal to d over d. Let me go fancy and use colors. I have du. What is y there? Y is cosine of u. Cosine of. So far so good, everyone? Everyone is following? Now, look at this one. This is multiplied to du over dx. I know that I can write this hammer, the operator, but instead, for u, I'm going to substitute the baby itself. What was the thing which I called in u? The baby. It was 1 plus x to the power 3. You see? For this part, I called u as 1 plus x to the power 3. That's why it becomes cosine of u. Now, I have d over dx, and my u is 1 plus x to the power 3. Oh, can you see that, Tommy? And all people at the back? Sebastian, everyone? Yes? Now, this becomes like this. Can I write it here? Can you see everyone? Yes? Now, look at this one now. Things seems to be a little bit more interesting. D of cos u over u. D of cosine x over x. These things are similar. Cosine of apple over the apple. Cosine of u over du. Then what do? You close your eyes and write it as what? Minus sine of u. Alright? This part becomes from this part. So easy so far, huh? Yes, Armand? Sounds fascinating, huh? Now, look at this. I have this multiplied into this term. Look at this one. D over dx of 1 plus x to the power 3. You all remember from 3 weeks ago that d over dx of a x to the power n is a n x to the power n minus 1. Yes? Everyone remembers that? He's an old friend. Now, d over dx of this term, it means that you take the hammer inside and put this on everything. D over dx of 1 becomes how much? Yes?
Why did negative something?
You mean this one?
Oh.
We accept it.
So the first one is just positive?
This one is positive.
Oh.
This one is negative. We take it as a Bible. We do not change it. Now, does it make sense now? Awesome. And now, d over dx of this term. Take this inside. D over dx of 1 becomes how much? 0. d over dx of x to the power 3 becomes how much? That's right, times 3x squared. However, it means that I'm just going to write it there. Is it okay if I write it here, continue here? Yes, let me erase this part. How did we start it? I'm not going to erase this because I'm coming back to this formula. We said that the y is equals to cosine of 1 plus x to the power 3. Then when I called the baby u, I got dy over dx. I'm going to write this part. Using this formula is what? Minus sine u times 3x to the power 2. Or you can just take this one over there, you do some housekeeping. You say, I'm going to take 3 over there. I have minus there, I have x squared, and I have sine u. And that becomes what? d over dx of y. What does it mean? It means that if the function is given like that, and now you just want to see how it changes when x changes dy over dx, you get to this very interesting formula, expression, sorry, not the formula, minus 3x squared sine u. You said, oh, I'm so sorry. Who was you? I forgot. Who was you? I say you was this one, the baby. Then in order not you come back to me and ask me, sorry, I do not remember who was you, then you substitute it back. Then it becomes minus 3x squared sine of, what was you? 1 plus x to the power 2. Now we are fully done. Beautiful, huh? Yes.
Is that the derivative of the original function, or is it just of y?
Derivative of the original function. The original function and y is the same. We say y is equal to f of x. And f of x is that expression. And we found d of dy over dx. Any questions? No? Means everyone understood? I'm a very good teacher now that everyone understood. Or, I'm a very bad teacher. You didn't understand anything. You are shy to tell me, what was those stuff? Now, anyhow, I'm just going to modify this formula. This formula can be modified to this. That d over dx of a function cosine of f of x. F of x is the baby. It was here 1 plus x squared. Becomes, look at this, minus sine of f of x times d over dx of f of x. You see how it works? You see that when you have a baby inside the cosine of the x, let me close the door. You see that when you have a baby, which is, for example, you learn that cosine of the x, I introduce you to this mother. Then she got pregnant with f of x. Now you just want to find the rate of change of the mother and baby. You say, okay, it becomes still minus sine of the mother, f of x, multiplies to the derivative of the baby. Look at this one here. Cosine of 1 plus x to the power 3. Then, as a result, the derivative becomes minus sine of f of x minus sine of 1 plus x to the power 3 times the derivative of the baby, which is 3x squared. Then, for the next 220 years, anytime you just want to use the derivatives, either you can just use this method, which is called the chain rule. Why this is called chain rule? Because look at that. They are like two loops of a chain. They are multiplied together. That's why it was inspired as the name of the chain. Either you choose the chain rule, it's everywhere is valid, whenever you see a baby and the mother. Or for the trigonometric function, use this one. Either is valid. How much time do we have? 1:15, you have to apply. Any questions, everyone? No? Everyone is feeling happy? Then if you are, yes.
Well, where did you get the dy over du times du over dx?
Where did I get that?
Yeah.
I played so smart. I said, okay, still, the whole expression is dy over dx. Because if you multiply them, this red one, you cancel out. But by doing so, you are able to find the derivative of the baby with respect to the x, and the derivative of the mother, which is y, with respect to the baby. And that's why from there, you end up to go there. And that's what they call that the chain rule. I wasn't smart. Someone before me was smart to say, okay, this is still the same thing, but now you also play with the baby.
Okay.
Make sense?
Yeah. So you do that to be able to find the derivatives of the baby and the mother.
That's so true.
Okay.
Yes. Absolutely. In my functions 11 class, I always use that's so true. And people call me, oh, that's so true. Now, if you have no questions, I'm just going to give you one more example with the sun. Then I just want to expand also this one to a new expression which involves the baby also inside. And shall I erase this one? Yes? Now, let's look at this one. A new function to find the derivative. I say that the function is f of x, which is sine of, oh my gosh, it seems something interesting to do, e to the power x. Now, look at this. For this one also, either I can expand this one, or I can use the chain rule. First of all, I look at this, and I say, oh, look at that. It's the mother, because it's just sine x. Now, it has a baby inside, e to the power x. Then when I see the baby, I say, hey, you. And that's where I call this one u. E to the power x, I call the baby u. Now, to find the derivative, I'm going to follow exactly the same thing. Then as a result, this function changes to be, let's call that y equals to sine of u. Let me see if I'm still on the camera. Yes. Now, in order to find the derivative, Sebastian, look at this. I'm just going to act smart. I say dy over dx. That's what I'm looking for, to see how the mother and baby they are changing with respect to the x. I say, okay, I'm just going to create this chain. This is a chain. Two loops of the chain. This one is dy, and this one is dx. Now, I put du on the top and du on the bottom. Now, if I look at this, I can find every term of the loop. dy over du. What is y? Sine of u. Let me just write everything. it becomes d over du of sine u. Look at this now. Now that you call the baby u, then you always have the function sine u. Then when you have dy over du, it's d of y, which is sine u, with respect to the u, multiplied to du over dx. What was u? U was e to the power x. Now, Cyrus, you say, that's so familiar now. I have the d over the apple of sine apple, which means that the x and the x are exactly the same. In that case, Tommy, it means that becomes cosine x. Then what you do, Brute, is that then you say that, okay, d of sine u over u becomes simply cosine of u. Because multiplies to d over dx of e to the power ex. What is the derivative of dx? That's right, because if you remember, we said that ex is the only functions in the universe that its changes is the same as the function. Then this one becomes ex. Now, let's say, okay, then dy, it is essentially what? Dy over dx. You have cosine u times e to the power x. But you say, after 2 weeks, you come back and you say, sorry, what was the baby called? I say it was u, and it was a baby. Then that's why you take everything back. I put u as the baby itself, cosine of the x. And now I can also write the x, do some housekeeping. I put ex at the back as a coefficient, and becomes cosine of ex. Oh, sorry, maybe that's too. I'm sorry about that. I went too big, and that's why I lose space on. Okay, any questions? Let me put this, that it shows that this is beautiful, huh? Then as a result, I'm just going to write this on the top. I can write it still here. Let me use a different color. Then as a result, you say that as an extension of this, we can write d over dx of sine of f of x. F of x can be anything. It can be also like e to the power x. Then it becomes what? It becomes the cosine of f of x multiplies d over dx of f of x. This is an extension. Like this one, sine of e to the power x becomes cosine of ex, which is cosine of f of x, times the derivative of the baby. Derivative of the baby e to the power of x, e to the power of x itself. Then it's multiplied to this. Yes?
Parents, will we have to show all this work or you?
No. You do not need to do on the test. You do not need to just show, unless I explicitly ask you, use the chain rule. Otherwise, if I say, do not say anything about the chain rule, just feel free to do anything. Any questions, guys? You have 20 minutes left? Now, you can just use 1 minute to do some stretching if you want, then you have 90 minutes. Go talk. Please, absolutely.
I get it. like, how do you know? Yeah, it's just.
Sorry, so you see how the calculus is beautiful? Triangle.
That is the way to go for it.
Okay. Let's get started with something new.
There we go. Next Friday? Nine to 10:30 on paper. I don't know why it's not. Next Friday, no second. This is vintage. Oh,
It's really vintage.
Okay, guys, please take a seat back. We have only, guys. Yeah, I Okay, now, we have almost 15 minutes left. How about, as our popular kind of problems, find the slope of the tangent line of the function which is given there at the point which is x equal to 0 at the origin. Wow. Now, I love that. What? Because it means that you really love that problem.
I love it.
Let me just put this one down. Cosine of the square root of x. Sine of cosine of the square root of x. We have 15 minutes left. Always remember, use this formula as a Bible that you just as you just move along. Yes. Over. Okay, now. Guys, look at this. Everyone focus, you're just going to deal with this one. It's a very, very comprehensive example that we're just going to do today. Look at this one. The first thing that you just get to notice of this equation is that you say, oh, look at this. It comes with a baby. This is the sine x, but it comes with the baby. And you say, hey, you. And you call the baby, and you call the baby u. And that's the reason you put u equal to cosine of square root of x. Now, it turns out to be like what? It turns out to be written like that. You say y equals to, I do not write f of x anymore, then it becomes sine of u. we said that, okay, in order to find the derivatives, either you can use the chain rule, which I'm going to do that myself, because it's very interesting practice. I recommend you initially use the chain rule because you need to practice on it. Then along the way, just use the formula. Then dy over dx equals to, I get dy here, dx over there. Then I have du here, and I have du here. You see that they are multiplied in chain rule, then it's essentially dy over dx. Now, I have dy over du. What is my y? Sine u. It means that it becomes d over du of sine u. Multiplies into d over dx of u. What is my u? Cosine of square root of x. Now, everyone is following me so far? Everyone is feeling happy, refreshed? Yes? Now, look at this one, guys. Something very strange is going to happen. Don't be surprised. d over d of sine u, d of x of d over x. It's cosine x. Then when you have u here and u here, it means that you right away like it as cosine of u. Now, you reach into this term, d over dx of cosine is square root of x. Sebastian and Brooke, look at this one. Now you have cosine, you expected to have the cosine of x over x, which is minus sine x. You see, oh, I have x here, j, and I have the square root of x there. Oh, wait a minute. What happened there? The baby pregnant itself. The mother was pregnant, and the baby inside the mother is pregnant again. Oh my God, that's a surprise. And that thing can go on. And now look at this, what I'm going to do. I say, guys, I'm just going to erase this part because how much time do we have? 5 minutes, unbelievable. Now the mother is a grandmother. And now,
Can you draw it? You said you would draw it in class.
next time, you do not have, you have only 5 minutes.
There's so much time.
You have 5 minutes. Look at this. I say, oh, there is another baby. I call it, hey, V. I have U for the baby itself. Now I call it V. Then what does it mean? I'm going to write it there. I say cosine square root of x is going to be called V. Then as a result,
Isn't it already u?
it's U. Oh, sorry. The square root of, thank you. The square root of x is V. It's the baby of the cosine. Now, in order to find the derivative of this, I say again, d of, again, I'm just going to call it, for example, the square root of, let's write this one as, I'm just going to call du over dx. This is what we want to do, du over dx. I'm going to write another chain rule. Another chain rule, I put du here, I put dx here. Now, I put dv and dv. I use another chain rule. And in another chain rule, I get du over dv. What is that u? Cosine, it's d over dv of cosine v. Because u is cosine of v, and now v is v, times dv over dx. This is v over dx of x to the power 1 over 2. Now, so I'm just doing it fast. This one becomes minus sine v. This time becomes times 1 over 2 x to the power minus 1 over 2. Then it means that I can bring it here and multiply everything to this expression. It becomes minus sine v times 1 over 2 x to the power minus 1 over 2. Now, what is v and what is u? I put them back. I call the babies again by their own name. What was the u? U was cosine square root of x times minus sine. What is v? V was the square root of x times 1 over 2 x to the power minus 1 over 2. And by the way, I remind you, I just use the power rule to find this. Yes, Sebastian.
Is that dy over dx up there? Is that du over dx?
This one
Yeah.
is d over dx because I'm finding this one. d over dx. I take this one here and I call this one v, and that's why I introduce v here. Because dy over dx is just started this. This is step 1, and this one is step 2. Next session that we meet, I'm just going to solve this something similar to this. This one, take it as a taster that you see that you may have someone is pregnant with the baby, and the baby itself is pregnant. We are going to work more on this stuff on the next session. How much time do you have? Oh, I thought that it should be done by now. Okay, now, guys, look at this. If you do not want to use the chain rule, I'm going to solve this again. I recommend you to take a note. The video is recorded. You can double check that. If you have some problems, what did I do? I'm going to solve this one again using the same formula that I gave you. I erased them. This one is f of x. You see two methods. We have given two methods there. Is the sine of cosine of square root of x. Based on the formula, is everything's fine? Based on the formula that you learned, first of all, on the formula which I erased, we said that the derivative is going to be the derivative of the mother. The derivative of the mother with the baby is cosine of square root of x. You see that we built this one, the first expression. Now, multiplies to the derivative of the baby. Derivative of the baby is cosine of square root of x. Now, you see that the baby is also pregnant. Then it becomes what? The whole expression becomes the derivative of the mother with the baby, which is minus sine of square root of the x, times the derivative of the baby, which is d over dx of square root of x. Now, this one is minus sine square root of x. Derivative of the square root of x, use the power rule. You change the square root to the power 1 over 2, then it becomes 1 over 2 x to the power minus 2. And now what we had before, we had also here cosine square root of the x. You compare these two, you see that everything now, we derived it. I didn't use the chain rule on this method, but I used those two formulas, which I gave that to you, and I wrote it here. I can say maybe you are a little bit, I should say, uncomfortable with this, but do not worry. Next session, when we come back, we are going to solve more of these ones. Today, it was a short period, and look at this as a kind of a taster to see how the derivative of trigonometric function tastes. It tastes sweet, huh? or retail. Now, then guys, remember, the chain rule we covered today, and also we talked about the derivative of the trigonometric. So, the next session that we show up, please everyone take a look at the page number 256. Exercises which you see that part A, 1 and 2, please do this. And they are going to be much, much easier compared to the things that we did over here. Yes?
Which page?
Page number 256. And I recommend you to do part A, exercise 1, and exercise 2. You see that these two ones are way easier than the one you solve. I just wanted to show you how extreme you can go. And I'll see you on Friday, huh? Or next week. Tuesday next week. Oh my God, that's so long time. Guys, if you have any questions, always send me an email.
Next week, what?
Oh, wait.